Well, then they've been there for a long time, because I know it wasn't the last couple classes. Okay, I do have, who wants the paper version of this? I did not pick it up. I'm gonna need the paper version today, did not already pick up. They were still here. Well, please put your phones away. I see all these video games, I'll just like snatching it out of your hand and taking it to the principal. Who else wants the paper version that did not pick it up? Today is the 27th, that is correct. What about you? You want the paper version? Okay. We have done some of this before. Okay? It was not going to be using the same language that we're going to use today. But I figured that we would go ahead and go back and go over this for multiple reasons. It's been a while since we've done it. Here's my screen. Today's assignment is fairly easy as long as you write the answers in the format that we want them in. Otherwise, I was instructed to take 20 points off the total grade of the assignment. So it'll be done just exactly like the sample. We'll go through what we're looking for. Once we get through this, it should not take too long. In fact, I expect most of you to finish, if not finish, come really close to finishing today's assignment and not have to have homework. We are about to start up in chemistry what is called stoichiometry. Please do not be afraid of the word. Okay, it's just a big, long word that means math and chemistry. We're going to take it little bit by little bit. And today we're making sure that you know how many of each element is present in the compound. So you have to be able to understand what the numbers mean in subscripts and parentheses. You do need to know the difference between ionic compounds, molecular compounds, and elements. So that is today's opener. What's the difference with, I mean, obviously an element is just an atom. It's 118. But what's the difference between something that's ionic and something that is molecular or covalent? Because those words are interchangeable. Goodness, y'all. What do ionic compounds always tend to start with? Metals. Okay, and ionic compounds are always, well, unless it's a polyatomic. Ionics are going to start with metals and they're going to end with what? Non-metals. What do molecular or covalent, these words are interchangeable, they're only made up of one type. What are they made up of? What? The other type, molecular or covalent. Remember, those words are interchangeable. They're only made up of one type of element. What are they? A what? Non-metal. I just didn't hear the whole thing of what you said. They're made of non-metals. Remember, on the periodic table, that red staircase, everything to the left is considered a metal, except for hydrogen. For hydrogen, it's just out of place. And everything to the right of that staircase, including hydrogen, is considered a non-metal. So once again, ionics start with metals. We normally end with non-metals. Yes, there are some exceptions with polyatomic ions, but we're primarily talking about binaries today. And molecular is the same thing as covalent. And those are going to be non-metals and non-metals. There are not metals and there are not polyatomic ions in a molecular or covalent compound. Molecular and covalent mean the same thing. It's just two different words that mean the same thing, and they're going to be made up of nothing but non-metals. We've done this. It's just been a while, so I know most of you. Well, so I know some of you remember, but some of you may not have gotten it. I know some people were remote and now they're not remote. Go back over first semester, so I'm just going to cover all my bases and sort of start from square one here. Okay. So note 33. Elements are one type of atom. Okay. This includes diatomic elements. The I2, Gr2, those. But it's still only one type of element. There's one capital letter and one lowercase letter. There's not going to be two capital letters because then it's a compound. It's not an element anymore. They're up there. Periodic table is probably older than me because we know all 118 now, and that one I don't think it has any of the bottom row. They all say UUU. Can't tell with the glare. But they all say UUUs down on the bottom. But we know better than that now. Compounds have two or more different elements that are chemically combined. They have to be different. So like water is H2O. It has 3 atoms in it, but it's made up of hydrogen and it's made up of oxygen. Different elements. So I2 is just iodine. It's an element. O2 is just oxygen. That's a diatomic element. Salt, sodium chloride, is a sodium and a chlorine chemically combined. It's got 2 different elements in it. But you should know the formula for water by now. You shall know the formula for water by now. This is sugar. This is normal sugar. 2 glucose that are chemically stuck together, which you should have learned about photosynthesis and stuff in biology. I don't know if that is if that's what you guys were learning when we shut down, with the spring break and never came back. I know what chemistry was doing approximately because I was teaching that last year also. I did not print out my cheat slides. I think there's one more on here. There it is. Subscripts. This was one of the vocab words from the test yesterday. Yes, the easiest set of matching was duplicated on there. I just left it. I had to go back and hand grade everybody's test because if you got one part of the matching wrong, it counted the whole thing wrong. So I had to go back and individually award you back the points of the parts you got right. I did that. They should be transferred over to Canvas. If there's any numbers after the decimal, round it up a whole point. I don't care if it's below 0.5. I went ahead and rounded it up to a whole number. Subscripts is one of our vocab words. These are the little numbers, which I have a new remote, so I'm still learning it. These are the little numbers that are after the element, okay, and they tell you how much of the element there are before the number. So in the sugar, the C12H22O11, there's 12 carbons, there's 22 hydrogens, and there's 11 oxygens. Most of us seem to have understood this part when we did this in a few weeks now. I'm missing a lot of people. Jared's here, Braden's here, Caitlin's here, Slate's online, here, Tiffany. Lucas, if you're online, I'll get you in a minute. I haven't seen you yet, though. Back when I saw, if you missed the test yesterday, I sent you an email.
What?
If you missed the test, how you can take the test and how much time you have to take said test. I did have at least one A in here. I had 1, 2 high A's in here, actually. You guys ranged everywhere from a 95, well, I had people not take it, so I guess technically a 0, but down to 25 it looked like. I don't remember everybody's off the top of my head, but they are on Canvas. So once again, the subscript is a little number, little down number, not the one in the front, those are coefficients. And that number tells you how many of the element there is immediately before the number. Now, when there's parentheses, the number outside affects everything inside parentheses. And we'll go back over that in case you forgot. Anybody still needs, because there's not much on here for you to fill out. I want you to be able to finish the assignment in class, or if you're working on it, be able to ask questions and I can help let you figure out where we're pulling this info from. This is calcium phosphide. There are 2 elements in it. There's calcium and there's phosphorus. How many of each do you have? You have 3 calciums. Okay, and how many atoms of phosphorus do you have? 4. I hope you remember going back over this. Like I said, I know some people were remote, there's quarantine going on, it's been all kinds of chaos this year. So, well, you need to be able to identify how many atoms there are in any compound I put in front of you. I know it is, but I'm still, like I said, but there are people who either, whatever reason, may have missed this. I'm going way back to square one because I can't lose people with the stoichiometry. You have to be able to build a formula right, and you have to be able to know how many atoms there are for each element in said formula to be able to calculate what's called molar mass, which we are doing tomorrow. Okay, this is a hydrocarbon. It's written differently than the way that you're used to seeing it. We'll start with carbon. How many carbons are in this hydrocarbon? There are 2. Okay, now, when we do the balancing, when you have a plus in between compounds, we leave it as addition. But in this case, if this was my hydrocarbon, I would go ahead and write it as 2 because they're both in the same compound. If I put a number in front of it, it's still going to affect everything inside the compound. So in this case, you could go ahead and tell me that there's 2 carbons in this molecular compound. How many hydrogens are there total? 4. There's 3 here and 1 more. But if you were using this in a skeleton, you don't have to balance them separately because they're in the same compound. It's when there's 2 different reactants or there's 2 different products that have the same element in it and there's a plus between them, you have to balance it that way. How many total oxygens are there in that hydrocarbon? There are 2. Once again, you would not balance it as 1 plus 1, but there are 2 separate oxygens in this hydrocarbon. Yeah, I know this is like ridiculously easy, but are there any questions how I figured out how many of each one? Because this is as straightforward as it gets.
Miss, could you see the number after the comment?
The only exception would be if they're listed more than once, and normally it is a hydrocarbon that does this. Acetic acid is very commonly written that way. That's the fancy name for vinegar. All right. A little bit more complicated. This is barium hydroxide. No. Unless if you miss this part though, as I said, it's how many bariums are in this compound? Just 1. That 2 does not affect the barium, it only affects the hydroxide. When we do molar mass, you list every element individually. You figure out how many they have, and then you pull a number we haven't used off that periodic table to figure out how many grams a mole would be for that compound. I know I have 2 hydroxides. How many oxygens do you have? 2. Okay, it's understood that there was originally 1, but this 2, I don't have a laser on this thing, so I'm having to, and if I don't point it at the screen, it doesn't work right. This multiplies both the hydrogen and it multiplies the oxygen. So how many hydrogens are in barium hydroxide total? 2. Well, when we balance, if hydroxide is on both sides, you keep it together. If we do molar mass, you're calculating each element's mass separately from each other.
How do you know which one you're doing?
What do you mean, how do you know which one you're doing?
Like, if we're doing more math or more, or like keep together separate.
Well, the one is balancing the skeleton of the equation, and the other one would be the fact that I know, and I have to look them up because I don't memorize all their masses. It would be, in the case of this guy, 137.23 plus 2 times 16.00 plus 2 times 1.01. We're using the bottom numbers off the periodic table that you're not used to using. And we're doing 2 numbers after the decimal. So you may have to round, but I'm literally pulling those point whatever numbers off of here, and however many I'm multiplying it by from the formula. Forward. Okay, it's not going to do it. This one, iron dichromate is what this thing would be called. Let's see, who else is not here? Okay, who's it from? I'm sorry, George. It's just more important. It's that contact for somebody. I'm sorry. It's not that it's my fault, but yeah.
I would like to get one thing after next Tuesday. Then I'm gonna have one.
All right. How many irons? Iron is Fe. How many irons are in this compound? 2. Does that 3 affect the iron?
No.
No, it only affects, and I know they can't see me pointing at the screen, so this 3 only affects the things that are inside parentheses. So I have 2 irons. How many chromiums do you have? 6. 3 times 2 is 6. How many oxygens do you have? 7 times 3.
21.
21. So if I was calculating the molar mass, but today is not molar mass, but I would do 2 times, and iron is 55.85. Chromium, I would do 2 times, and then its mass is 52.00, because that rounds up. And oxygen would be 21 times 16.00. Yeah, I'm literally pulling those decimal numbers straight off of here. And I don't make you memorize that stuff. You just don't have to be that part yet. Most of you will actually like doing just molar mass. Because as long as I give you the formula, it's however many times the mass off the periodic table. It's doing the conversions with molar mass. It's a little bit more complicated. Okay, ionics are made up of metals, which is to the left on that periodic table is the red staircase, not hydrogen, including everything down on the bottom that's right above Jared's head, the inner transitions, the ones that are separated. And normally a non-metal, which is something to the right-hand side of that staircase, including hydrogen. Ionic compounds are not called molecules. They are compounds, but they're not molecules. They are called formula units. It's just, this is where somebody in my 8th period, she always goes, why? Is it because whoever invented chemistry said so? It's whoever it was that identified the language of chemistry said that a representative particle of an ionic compound is not a molecule, it is called a formula unit. Well, it's been this way for forever. Who else is not here? That one's not here. I do need to double check online. So, Haley's here, Kyle's here. You can see Veronica yet, she did be online. Harry's here, Robert. Let's see, Reagan, but she may be online. Reagan, maybe online. George just posted. I think that's for loading this too. I had a whole bunch of people quarantined since the beginning of the week, so. What lattice means is when these metals and nonmetals form up with each other, the positive and negatives, they line up magnetically, if you will, electrically. They make almost like a box-like shape. They have a very specific pattern, which they call a lattice, that they arrange into. Like I said, its particle is called formula unit. A molecular compound or a covalent compound, which is the other acceptable phrase for this. They're only composed of nonmetals. So boron, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, iodine, bromine, chlorine. Yes, hydrogen's included to the right of that staircase. There are no metals. A molecular compound, its smallest thing, including the subscript. So like a molecule of water is H2O. That's what it is. It's not a formula unit, it's a molecule. It's just a matter of keeping the right particle, the right word with the right type of particle, the right type of compound. Okay, now both compounds, ionic and molecular, are made up of atoms. If you have an element, its particle is an atom. If you have an ionic compound, its particle is a formula unit. If you have a molecular compound, pardon me, its particle is called a molecule. Whoops, we go backwards. At least this will go backwards. The other one will not. Let me check online real quick before we go through that chart. Who is online I did not see before? Now I got Alexis, Lucas, Reagan, Tatiana. Okay. No, they're fairly short. Let me get the right slide back up here. I need to show you what you're supposed to be doing for the, oh, that's frozen. Unfreeze it. So your assignment, which I may as well start passing out, if you did not already pick it up, is going to look exactly like this. Okay, those are not any of these on here, so don't think it was pulling them out. We did not pick up the assignment for this. Nice, put it away. We're going to follow a very specific format, just like the way it's going to be up on, just up in the front, these are yours. And with the fact that we have, literally, we're gonna have 20 minutes left in class, I expect some of you to watch this really quickly. And that much, okay, so I guess that's it. Because next week, this is about to get a heck of a lot more complicated. I like this part of chemistry. I like stoichiometry, but I'm weird like math. Okay, we have carbon dioxide. How many carbons do you have? One. You have 2 oxygens in it. If you see on your paper, like if you look at the homework thing, I want you to tell me not only how many numerically, but also next to it, well, you don't, yeah, go ahead and use parentheses, because if you write 2O, it looks like 20. So not only how many of each element, but also what is its symbol. Carbon dioxide, is it going to be, is it an element? Is it an ionic compound, or is it a molecular compound? It is molecular. Now, I know that because these are both non-metals, but also when I named this, it's carbon dioxide. And if you hear prefixes, those are moleculars. So the particle of a molecular compound, is that an atom? Is that a formula unit? Or is that a molecule? It is a molecule. Do not abbreviate molecule as MOLE or MOL. That is a mole. We have not gotten into moles quite yet. We are about to. In fact, you guys have on Friday, how you guys are all remote, we're supposed to be like, I don't know, doing stuff from in here. I'm leaving the mole tube behind for you guys to do. Everything is in Canvas, where you're doing, hopefully you know what puns are by now, they're play on words, and you're creating on a regular piece of paper, a regular sheet of white paper, not notebook, you're creating a cartoon representation that has to include a mole. And I put it's a poster board version, I don't want you to make one that big, where I had a student and she did Miley Cyrus when she went crazy like 5 years ago, and like the whole wrecking ball, like wearing next to nothing, and she just went nuts. So she made Molly Cyrus, and she put the mole literally on a wrecking ball, and it was swinging back and forth. And she put Avogadro's number on it. Now you can't do Miley Cyrus with Molly Cyrus, but you have to have a mole in it. I know the mole is a representative particle in this class, so you have to have a mole, like the little critter with the big teeth, and it has to have Avogadro's number on it. We'll talk about tomorrow. And all the other directions are in there. You have a week to get it done for next Friday. So Ag is silver. How many silvers are in silver? 1. Is that an element, an ionic compound, or a molecular compound? Which one is it? That's an element. So is a representative particle of an element an atom, a formula unit, or a molecule? It is an atom. Now we have chromium sulfate. I think that's supposed to say Cr2SH43, but I'm not changing it right now. I don't want to confuse you. So, how many chromiums are in it? 3. Okay. You have 3 times 1, which is 3 sulfurs.
Why is everyone splitting?
Yes, you are too, each individual element. When you balance, if SO4 is on both sides, you balance it as SO4. And however many you would have it be outside. But sulfate is made up of 1 sulfur atom and 4 oxygen atoms. That 3 outside multiplies everything inside. So 3 times 1 is 3 sulfur atoms. 3 times 4 is 12 oxygen atoms. Is this an element? Is it ionic or is it molecular?
What was the first
Chromium. Cr, chromium.
one?
It is ionic because chromium is a metal. Also, sulfate is a polyatomic ion. So this is ionic. Is a representative particle an atom, a formula unit, or a molecule? It is a formula unit. Now, in chemistry, guess how we abbreviate formula unit? FU, we do. No, you did not just tell me something bad. So yes, I do not care if you represent formula unit as capital F, capital U. I know there are so many jokes in there. I've only taught chemistry for well over a decade and I've heard them all. No, I did not take offense by you saying FU to your teacher. You giggle. I've heard it year after year after year. You want to write the whole thing out? You can. And so, honestly, y'all, that's all you're doing right here. You're identifying how many of each element. You need to tell me the element in parentheses. So the first letter needs to be capitalized and the second letter needs to be lowercase. Then you're going to identify, is it an element? Is it ionic or molecular? Then is that going to be a representative atom, formula unit, or molecule?
There's not parentheses around it.
Like which one?
For the NA2,
Uh-huh.
CO3.
Uh-huh.
Just without parentheses on it, the carbon still be 1.
1. That is correct. No, the oxygen has 3. And honestly, I expect some of you to finish this in class. Let me freeze this. I'm pretty sure that was the last thing that I was going to do with you. Yes. Really short. Very easy. For the test, who missed it for whatever reason, shape or form, I have no grade for you. That would be, well, that person's not here. I don't know if Veronica is online or not. I didn't see a second ago. Matthew, well, Logan's not here. Tatiana. I need to double check yours. Oh, no, I'm sorry, not Tatiana. I can't read in a straight line. Aiden, Robert, and Jeremiah. You were supposed to take your test yesterday. Let me stop this real quick. Stop.